Welcome to Mindful Machines. Today we are going to discuss a first subject that is Python. So before heading towards Python, we need to understand why do we need a computer language. See, we need a computer language to communicate with machines slash computers. So it helps us to communicate with the machine. And like all human languages, computer language has also some structures under a language, which is like vocabulary, which can be interpreted as libraries and functions in a programming language, grammar, which is a syntax in a programming language, and an execution. See, what is execution over here is, for example, you have a brother and you ask him to get something for you. Now, he might not execute it during that time. He might procrastinate it. He might feel lazy about it. He might will go and get you something, whatever you have asked for, but might not be during that moment only. And he could deny that thing also. Unlikely, in a computer, the execution is always immediate. It never denies. It only tells you if the syntax is accurate, if the vocabulary has been used properly, it will execute the output. And all of this is built on a structure called as input and output. In a human language, it is generally a sender and receiver. So if you're sending someone message, you receive message from someone else. And that is on a very basic scale translated in computer language as input and output. Now we need to understand the computer language. See, when I ask you like what is a computer language, most of you will say it's C, it's Java, it's PHP. But see, this is built on top of computer language, but this is not the core, the essence of the computer language. The essence of the computer language is the binary code, sometimes also represented as a hex code, but a very base form is a binary code. Computer can only understand in terms of 0 and 1. Now, see, this is very complicated. If you need to communicate with a computer, you cannot remember some specific machine codes. For example, this is a machine code. Now, independently, you cannot identify what does it do. And even in a very complex logic that you create while coding, it will be a very tedious job to understand what this line is meaning without referencing to a manual. This x01 is basically referred as a print function. So what scientists did was they created a language that acts as an intermediate between human and the machine code. Now that language translates whatever the human write in that particular syntax to the machine code. So this is easy, but the first coding language, first programming language was still not that easy. So many variations came, like many users, many scientists built one language on another, and this kept on happening until the day like C or C++ when we finally nailed it. When it was like, okay, this is a language that could be still used and it's very easy and it's really powerful. Now, before moving ahead, I want to bring your attention towards a very basic topic. That is the medium of translation. So whenever you write a code, it is being translated to the machine code. Now, how does this happen? This happens in two ways. One is compiler and another one is interpreter. So what is compiler and what is interpreter? A compiler converts a code to machine language and then executes it. So it basically converts your whole script to a machine language in 0101 and then executes it. Then asks computer to execute the output from it. But unlike compiler, interpreter is converting and executing the code line by line. So it goes in a very line by line methodology, which is like it takes one line and then it converts it, then it takes another line and then it converts it. So this is called as interpreter. Now let us move to Python. See, Python, first of all, it's a very high level programming language, means that it has high semantics. Now, what does this mean? High level programming language or high semantics is generally referred to a language which is as close as to human language. Now, in Python, you can just simply write a code something like this. If A is greater than B, then print B. See, this is very close to English, human language. You don't have to write x01, 002, C out, C in, etc., etc. It's a very high level programming language. Secondly, is it has a very powerful community and libraries. There's so many sources available on Python, and there are n number of libraries built on Python or for Python, built some using some another language, but is built specifically for Python. Then third is it's an interpreted language. I recently explained you what's the difference between a compiler and interpreter. Just like that, Python executes the code line by line. It converts the code line by line, it executes the code line by line. See, the focus on creating Python was that you don't have to worry about creating a logic or discovering how to code. It is meant to be like it is for those who just want to do a particular task instead of focusing on how to code. So Python is such a high level programming language, it helps you achieve that thing. But unfortunately, comparatively, it is very slow than other common languages. Unlikely, there are many reasons to it, and we'll understand it as we'll start to progress in a module. But till now, I just want to give you a brief about it. It's a slow language compared to others. If I can recall properly, a task that C++ takes 1 second, Python will take it 12 seconds. So it's, I guess, 11 to 12 times slower than C++ or C. And there are many variations right now being done to Python new versions, and they're constantly improving the speed. So we can hope that in future, the programming speed or the execution speed will be way faster than what we are observing these days. Now we are going to see Python in practice, and we'll do some fun experiments with Python. And there's a platform, there's something called as IDE, which helps you to write in Python and execute the output, and basically establishes a connection between you and the machine using the language Python. So many people use Jupyter Notebook or Jupyter Lab. Someone might be using something as Spider, or there are variety of IDEs available. But I prefer to use a cloud-based platform because see, this is one of the modern ways of coding. And secondly, if you'll work somewhere as professional programmer also, you'll generally use a online cloud-based platform. So to code in Python, you can simply go to kaggle.com, and once you sign up over there as a user, you'll get this option to create. Once you click on create, you'll get an option to create a new notebook. Once you create a new notebook, it will take you to the editor page. It will take some time to run. And once it will run, you'll see this code. Right now, you don't need to focus on this. You can simply delete this. And you can rename your notebook as you would prefer. So this is done. See, a very basic application that can be written using a programming language that uses input and output is a basic calculator. To do basic calculation on Python, it's extremely simple. So you can write something as 4 plus 5 and then click on this play button. Once you click on this, you'll get your output as 9. You can, and similarly to subtract, you can use 35 minus 5, and then instead of clicking on this play button, you can also click on Shift plus Enter, and this will run. To multiply something, you can just simply say 35 into 5 and use asterisk, and this will get you the output. To divide something, you just need to use a slash and you'll get the output. To divide something that is not properly divisible, that is also possible. You just simply write using slash and you'll get your answer in decimal form. See, this is all numerical way of getting the output. How can I return a alphanumeric message from the computer? To do this, I can simply use a single quote or a double quote and pass the message inside it. So, see, a very common ritual among programmers is to write their first program and output and get an output of hello world from the computer. To do the same, you can use something like code your message inside single quotes or double quotes, and you can run this. So this will output the message whatever you have typed. And it's not compulsory that this will run on hello world. You can write anything inside this double quotes or single quotes. Now, what is the recommended way to print? See, the problem with all of this is that this is only compatible with the notebook. And Python has two forms. Python has one form as notebook and the another form as a script. Notebook does not ignore this kind of operations, but a Python script will ignore and in some cases could give you some error also. So the better way to do is the recommended way to print is that a Python script will also not ignore is using this print keyword. Type print and then use open brackets, then inside double quotes you pass your message. Once you run this, you will get your output. And it is not compulsory that you pass a string value only, you pass a alphabet or a text output only. You can print anything. Whatever we have done here, you can do this under this string. So if you run this, you'll get your output as 5. Now you need to keep in mind you cannot break the syntax. I have already told you that syntax is like grammar of computer language. So a interpreter or a compiler is like do whatever you want to do, but do not break my syntax and do not break my vocabulary. I'll pass your message to the computer, but do not break this. See, what happens if I'll do this? If I'll do this, this will give me an error. And Kaggle is so smart that it tells you that you require parentheses around print arguments. And then only this will work. And similarly, if I just modify the result, I will get the correct output. Now let's increase our pace and dive into the deep topics of Python. Let's start with variables and identifiers. Variables and identifiers are a very connected terminology, interconnected terminology. Variables refer to like storing something, like storing in a box inside the memory of your computer. On the other hand, identifiers are a tool, a naming convention that you can use to uniquely identify a variable, object, or a function. The example for a variable could be used such as like lunchbox. You're carrying a lunchbox and inside your lunchbox there is food items for you to eat. Similarly, a variable is something like a storage box only. Although identifiers are a little bit different. Now consider the example, your mom is preparing food for you and your brother, and you both have a same to same, exactly ditto same lunchbox. Now, this will create confusion among you, like which one is yours or which one is your brother's. So, to avoid this confusion, we have some set of rules of identifiers that we use. The first rule is that the identifier naming convention should start with A to Z either in lower or uppercase or underscore. So the first letter could be only this, it cannot be a number, it cannot be a special character, etc. The second thing is that in between you can use alphanumerical values, including underscore. So you can use A to Z either in upper or lowercase. You can use numbers or you can use underscore. And the last thing is it should not be a Python reserved keyword. By this, what I mean is, see, keywords in Python are basically a reserved words that have predefined meaning and you cannot use them as identifiers. Consider this like you have a family and you have a siblings of 5. Your mother won't name every child the same name. A mother won't name you Michael if there's an elder brother already named Michael. She will try to create a separation. And similarly, in Python, even if you have not written a single piece of code, there are some reserved words. and that we cannot use to identify an object. Now let us dive into the practice. Now let us understand variables and identifiers through practice. Earlier I gave you an example of 4 plus 5. And now what I'm thinking is after addition, I need to reuse this element. How can I do this? Here comes variables and identifiers. I earlier told you that variable is like a storage box. It helps you to store values inside it. Just like a lunchbox, you store food items. Here you store data types, functions, etc. So whatever you pass, it will store that. So I can just use A is equal to. Notice, I am not breaking any law. A is following all the rules of identifier. First of all, it starts with A to Z, either in lower or caps, and here it's starting in lowercase letter, and it's fine. In between, you can use any value, and it is not a Python reserved keywords. So if I run this, you'll see there is no output, but there is no error too. Now, if I call this function, you'll see it's showing 9. Now I can use it to multiply with something. Let's say a into 10, and I get a result as 90. Now, what about if I name something like this 1a is equal to 2? This will not run because see, right now I'm breaking this convention. Starts with A to Z in capital letters or underscore, and it is not starting from uh, the first rule of the identifier naming convention. It's starting with numerical digit, hence this will give an error. See, instead I could use something like this: a underscore 1 is equal to 2, and once I call this, see, this will store that value. Now let us come to the topic of keywords. See, keywords doesn't need so much attention, but for just your knowledge and for your information, I'm going to share you the list of keywords in Python. So to do that, you just need to type this. Right now, you can just ignore what this import does and what it does not. So once you type this, you can just print out the list. And to print out the list, you can just simply write keyword dot kwlist. Once you'll run this, you'll see these are all the keywords that in Python are reserved, like false, none, true, and, as, async function, from, or, if, import, etc. etc. So these are all the list of reserved keywords. One tip actually I would like to share with you is one interesting tip I would like to share you is the power of this underscore. See, earlier I told you that you can use any name in the start also underscore. But what happens if I just use underscore and if I run this? See, it is printing out the last calculation, the last variable I have used. uh, let's say I do something like this 2 plus 5 and I then call underscore. It will be 7. Is 2 plus 5? Okay, this will might get complicated. Let's say I assign a new variable and I use this. What will be the value of x? X value will be 7. This is the power of underscore keyword. Sorry, not keyword, underscore just character. So a single underscore in Python act as the output, as the storage box for your last output. It will keep on getting updated. You cannot assign your self any value to it. It will keep on getting updated as you go through outputs. Now let us start with the quiz. Soon on your screen, you'll see some questions. You'll get around 30 seconds to answer these questions individually. And since this video will be uploaded on YouTube, I request you guys to do not cheat or sneak ahead of time. And please be honest to yourself. This is for your benefit only, and I'm trying to create an interactive session. Now let's start the quiz. Now, as I have told you earlier also, that according to the rules of identifiers, it is allowed to use underscore as the first character of the identifier or the variable. Next question. I told you like you cannot use any special characters apart from underscore after the first character also. You can use numbers afterwards, but you cannot use any special characters. Here, hyphen is acting as a special character. Next question. See, this is not breaking any convention. Print is a function, first of all. Print is not even a keyword. And secondly, it is using underscore after the print. So it will result into no error and it will result the and it will print the following value. Let us move ahead. Data types right now. Now let us jump to data types. So in Python, now let us jump to data types. See, data types in Python is way different from many other languages. Data types in Python are dynamically typed. It's a dynamically typed language, which means that you don't need to define what type of the data it is while creating a variable. It automatically assigns a data type during runtime. When it's executing, it assigns what data type it belongs to during that time only. Now, in many other languages, it is generally statically typed. So, by statically typed, I mean like in C, C++, you need to declare a variable whether it belongs to the integer family or character or a float family. So, like in Python, we just define a variable as a equal to 10. There, we might need to define it something like this: int a is equal to 10. Then we come to primitive data types. See, these data types are the basic fundamental of a programming language. These are like the basic units of the programming language. And non-primitive data types are the more complex data types that are formed using these data types. See, one of this example is like speed is a very basic unit. Time is a very basic unit. Sorry, let me reframe myself. Distance is a very basic unit, kilometer, meter, or in whatever measure you are taking. Time is a very basic unit, whether in time, whether it's in seconds, hours, or minutes. But speed is a complex unit. It is created by using two different units, kilometer per hour. So similarly, non-primitive data types are similar in this way only. They are more complex data types that are formed by combining primitive data types. Now let us understand the different types of data types in Python. So first of all is numeric data types, which just consist of integer, float, and complex number, like all those imaginary and real numbers. The second one is sequence data types. So these are the data types which consist of generally a sequence of letters, a sequence of data, or something like this. So strings, lists, tuples. Then there is Boolean data types, which generally means true or false. Then there is none data type. It's a very essential data type. Set data type actually lists tuples and this mapping data type, which is dictionary, we'll discuss in later in our course. Because since this is for beginners friendly, I'll just cover right now integer, float, boolean, and strings. Slowly and slowly, we'll cover all the advanced parts of it also. And all this is covered under a first class citizen. I'll explain you what this is. Basically, it means that everything in Python is object, whether it's a data type or whether it's a function or whether it's a class. Everything in Python is an object. Now, you might not relate with this word object, but soon we'll discuss about how to create classes. We'll discuss on OOPS, object-oriented programming. There you'll understand properly why in Python everything is object. But uh, just to grab this concept, I'll advise you to remember this, that everything in Python is object, which essentially means that everything can be treated similarly like an object. It can be passed, it can be returned, it can be considered as a data type, as an argument, etc., etc. So when I said the data type is numerical, so if I assign a is equal to 5 and I'll just call print a, see, it is telling me it's 5. But I need to check what data type it is because as I have told you, Python is a dynamically typed language. We don't need to specify what data type it is. It is checked during the execution time. So it's some autonomously it assigns a data type to your variable. So to check this, you can simply use a word called as type. And if you pass that variable, it will tell you it's an int. Now, similarly, we can do with something like 5.5. See, this is a number, and sorry, 5.5. And if I print a, or I'll just change name. Now let's run this. See, it's 5.5. Now I need to check what data type it is. I can just simply write type p, and I'll get a float. See, there is complex number also, something called as complex number. But I'll not start with that right now because it is a little complex to explain you guys how this will work during the initial stage of your learning. So I'll just skip that for now, but we'll cover later on how to use the complex numbers. Now let us jump to the string. So how you can create string is very simple. You can just type hello world and store it the way you like it. So if I just use type A, see now it will show as string. Similarly, you can also add some special characters also 1, 2, 3, but inside double quotes or single inverted quotes. You can use any words you would like to, or like I'm using at the rate 2, 3, 4. Let's make it a little bit complex, and that's it. So if I just call it type A, you'll still see it's string. Now let us jump to Boolean. So Boolean, to assign a Boolean value, you just need to write true, but the syntax should be same. You cannot write all in capital letters. This will create an error. You need to write exactly in this format. So if you do something like this and you just ask it, it will say bool. So this means it's a Boolean value. Similarly, you can do for false also. So once you type B and you'll call this, and you'll get a result as bool. Now, how to assign a none type? You can just simply use none over here. And once you use type function to understand what type it belongs to, you'll receive none type. A, we can try with something else also. B is equal to none type, and sorry, B is equal to none. And let me just see what it prints. It prints none, simply. Now there's a concept called as typecasting, which basically means converting one kind of data type to another. And there is one kind of order that you can follow. So before understanding the order, let's understand how this is possible. Let's say A is equal to 5.5. Uh, why this is happening? A is equal to 5.5. Once I print A, you'll see something happens like this. But what happens if I use something int A and I just print A right now? You'll see it's 5. Now I just want to check what's its type. It is int. See, this is how you can typecast to anything. You can typecast a number like, let's say you have a number like 5 and you want to typecast it to float. You can just simply pass this and you can ask type B and you can also print B. It is 5.0. See, it is 5.0. Print. Right now you don't need to look why something like this has happened, but if I just use over here, you'll get an answer. For right now, you can just skip why none is coming over here. This is a concept related to functional programming. We'll discuss it later. So just for your ease, I'm just moving it over here and I'll just call this and then I just call this. And you can typecast to something like string also, like strp. See, notice like a string, like a single inverted quote over here is present. So if you just use type, you'll get your answer as string over here. Now, what is first class citizen? For first class citizen, you need to know about a function which is called as is instance. So if I pass any variable over here, let us pass a, and let me first print what is a also. So a is an integer over here. So if I just say is a an int, I get the answer as true. Is a float? I get answer as false. What about if I write object? It is true. Okay, great. Is instance b? Let me check what b is. B is a float. So if I just call is B int uh, is instance. So is it int? I get a false. When I type is it a float? I get true. If I type is it a string? I get false. Is it a bool? I get false. Now if I type is it a object? I get true. Now what about is instance print? Print is a function. If I type int, what I will get over here? It will be false. If I type, let's say string over here, what I'll get? False. What if I type object over here? I get true. So everything in Python is literally an object. So even if I type something over here like just a number, is it object? True. See. So this is what is called as the first class citizen principle in Python. So everything is object and everything can be passed, can be returned. You can manipulate it. It's basically taken as an argument. Now let us start with the quiz. See, as I have told you, everything in Python is an object. Again, everything in Python is an object. Now let us understand the memory workflow. See, this is really important. There are basically three types of memory workflow that is happening behind the scenes. First is small integer internal. See, I'll give you an example. For example, you go to a library and you want to buy Harry Potter. Now you know Harry Potter is one of the most famous books. So does it make sense that you need to go deep inside the library and pick that book and then ask that librarian for a issue or something like this? It does not make sense. So all these famous and popular books are generally present near the reception or near the entrance only. So similarly, a Python also associates one of the most common numbers that it deems as most popularly used already loaded inside the memory. So small integers from -5 to 256 is already and pre-located in the memory before even you before even you run your first output. So whenever you open a Python console or something like that, it has already loaded -5 to 256 inside the memory. Now there is something called as string interning also. So now let us take an example of a supermarket. You order a few balls and you get tons of red balls. Tons of red balls. Now, does it make sense to keep it in all these balls in a different room, or you'll just keep all these balls in a single room? You'll keep all these balls in a single room. That's what basically string interning is. So inside, if there is a string and it has same value and it has no space in between, the Python will reference to it the same object only, to the existing object which has the same value. Now there is a concept of garbage collection. If Python observes that there is some memory that is not being used, like whatever the object present over there has not been used at all, so it will deem it to be considered as a garbage and it will remove it automatically to free up the space. So let us start with integer and internal. Let us say I have a value a is equal to 5. I have another value also which is b is equal to 5. Now in Python to check a address of a variable, what you can do is you can simply type id and you can pass on the variable. So if I do something like this, print id and then I say print this also, both the IDs. And I am also passing like this is memory location for B and this is memory location for A. Now let's run this. Oh, I'll just see what you are observing over here is. Oh, let me just. Ah. So what you are observing over here is that both of these locations are same. Now what will happen if I just change this output? If I change something to like 256 and this is 5. Obviously, both of these numbers are not same at all. What will happen? The memory location of both these elements are different. Now what will happen if I do something like this 20 and 20? The memory location of both these elements are same. Now what will happen if I do something like this 545, 545? The memory location for both of these elements are different. I told you that the small integer interning happens only for values from -5 to 256. So Python automatically pre-allocates memory for -5 to 256 inside the memory while you start Python. Before you start Python, all these memory options are already, all these elements are already preloaded into the memory. Now let us jump to string interning. What will happen if I print this? See, both of these locations are same. I have told you if there is no space in between, no matter how long you corrected you put, the location will be always same. Let's test this theory. So I say now hello world. I say now hello world. See, the location is now different. But what happens if I do something like this? If there is no space in between, what will happen? See, now the location is same. What will happen if there is a hyphen in between? See, the location is now different. So there are few special characters that you have to keep in mind, which can change the location, which can change a string's location. Either if you use underscore over here, you'll observe the location is same. But if you use any other special character apart from alphabets, or you can even use number two, so number won't be an issue. So even if you do this, the location will be still same. But if you use a hyphen in between or any other special character, the location will change. The location will be different. And this doesn't matter how long the string is. So if you just keep on using, let's say if you use something like this. See, the location is same. The string is very long, but the location is still same. So this is what string interning is. And garbage collection happens behind the scenes. It's kind of a black box. We cannot observe it, but it's just for your general information how this happens. Now, one more thing I need to tell you about is operator. See, just like how we are comparing above A and B location, I can simply use A is B also. So if I use A is B, it will automatically compare their memory locations. So this is true. Now what if A is 5, B is 6? Will A is 5, A is B true or false? It will be false. What if I use something like A is 6, B is 6? It will be true. What if I use something 500 and 500? It will be false. What if I use something A is equal to hello and B is also equal to hello? This will be true. What if I use a special character over here? Sorry. This will be false. So this is a very essential concept that you need to learn. Now let us jump to quiz. So as I have told you, is a comparison operator used to compare memory locations. So if both of these elements are on same location, it will just result true, else false. This is false because see, B is a float type and A is an integer type. So obviously both of these locations can't be same. Even if the values are same, doesn't mean that their data types are also same. So the Python must have given it a different space, and decimal values also take a higher space than compared to integer space. So that's why this is false. So as I have told you, no special characters are allowed apart from underscore for string interning. If there is a presence of any special character, it will assign a different location for that variable.